Okay, on Friday, we started talking about lesson 7.1. Okay, lesson 7.1, we started talking about these exponential functions. Recall, we did some graphs that look like such. We talked about if we didn't know what the graph looked like, we were doing the XY charts, so we came up with this curve. Remember, it runs along that x-axis, does not cross the x-axis. That x-axis acts as an asymptote. What we were talking about, I think in your class, is we were looking at the form of exponential function then. And the idea that an exponential function is of the form y equals a times b to the x. If you can get something in that form, where it's a number times a number raised to a power of x, that is our exponential function. Exponential form. Excuse me. We talked about A. A stands for the initial value. So like if you're in science, your initial value where your experiment started or something. It's also on your graph, it's the y-intercept. B, we talked about being the rate of change. If that base, B, is a number greater than 1, then that is like parts A and C up above, and where it's going to be exponential growth, where that graph is going up. Okay? If B is something between 0 and 1, which is like part B up here, then it's going to be exponential decay, and you'll notice that graph is going down. Okay, whereas A and C, my graphs are going up. Let's see, what else? The domain in all of these is always all real numbers, because you can go infinitely left and infinitely right. The asymptote, until we start moving these graphs up and down, is always that y equals 0, which is the x-axis. And the range, that asymptote is y equals 0. The range is everything above it. So y greater than 0. Okay, so some details there. What we were getting ready to do on Friday is being able to take a problem like this and identify, is this an example of exponential growth or exponential decay? And then also, what is the y-intercept? Or, in other words, what is the initial value? A, y equals 12 times 0.95 to the x. Thoughts on whether this is exponential growth or decay? Why? Okay, so what number do we look at to decide if it's growth or decay? The one in the parentheses, the one that has the exponent. So what has the exponent of x? Is the 0.95. What do you know about 0.95? Yeah, it's between 0 and 1, yes? It's less than 1, between 0 and 1. And so for that reason, I know that this is exponential decay. Now, the other question asked, so I know it's decay because of that 0.95. Y-intercept, or initial value if you want. Where do I find the y-intercept or the initial value? My A value, what is my A value here? 12. So right there, that number out front is my y-intercept. The idea is a y-intercept, if you recall, is when you put 0 in for x. If I put 0 in for x here, 0.95 raised to 0 is 1. 12 times 1 is 12. So my y-intercept is 12. Now, for me, I'm okay if you say the y-intercept is 12. I feel like MathXL might want an ordered pair based on what I have written down here. So what is a y-intercept of 12 as an ordered pair?
0, 12.
0, 12, because that means 0 went in for x, and 12 is my y-intercept. So a decay and a y-intercept of 12. Questions on that? Okay, let's try B then. B, y equals 0.25 times 2 to the x. First question, growth or decay? Why?
Because the number is bigger.
Okay. So right there, guys, you are looking at whatever is raised to the power. So in this case, that 2 is bigger than 1. So that is going to tell me growth. Y-intercept. What is that y-intercept going to be?
0, 0.25.
Okay. So remember your y-intercept is that a value out front. And again, if it's for me, I would probably just accept a y-intercept of 0.25 if you're saying that. But as I said, Math Excel, we also need to be able to state this as an ordered pair. So it's always going to be 0 something. So in this case, as you guys said, 0, 0.25. Okay, questions on those two? Notice on those two, you're given a function, right? You're given an equation. You're looking at that. Look at C now. C is more words, so it's more thinking about it. You put $1,000 into a college savings account for 4 years. The account pays 5% interest annually. We don't have an equation to look at, but use the idea of what this, the situation here. Is this an example of exponential growth or decay?
Growth.
Okay. Someone tell me, why would you say growth? Yeah. If I'm putting that $1,000 in there, and this account is paying me 5% interest annually, is that $1,000 getting bigger or smaller? We're going to hope bigger, right? Otherwise, this whole idea of a bank account interest doesn't really make sense, does it? So this is an example of growth because it's paying 5% interest annually. So that right there is what, to me, says growth. Now, the question asked for the y-intercept. Up above, I defined what's y-intercept. What is that also? Yeah. If I think in terms of like, in a science problem, okay, when you're talking about growth and decay in a science problem, your y-intercept is your initial value. So what's my y-intercept going to be here? Because where did my account start? It started at that $1,000 I deposited in there 4 years ago. So when we get to the back of the notes, you'll see we're going to work with money a little bit and look at growth and decay in that sense. Okay. If you guys are feeling comfortable with that, we'll go through the bottom row real quick and then get to the back side of the notes. So D, y equals 3 times 4 to the power of x. First question, growth or decay? And why is it growth? What's bigger than 1? Okay, just checking. So because of the 4 being bigger than 1, it's growth. What's the y-intercept on this one? 0, 3. Okay, E. Growth or decay? Decay because? The number with the x as the exponent is between 0 and 1. So 0.75. Y-intercept?
0.11. Oh, 0.11.
Okay, grab the correct number. Easy to make that mistake. 0.11. And F. You put $2,000 into a college savings account for 4 years. The account pays 6% interest annually. If we're saving money for the college, this better be an example of what? Growth, yes? How do I know it's growth? Yeah. It's adding 6% interest. Okay, and we'll talk about on the back side what that value will be. So definitely growth. What is my y-intercept here? $2,000. Okay. On the back side, we are looking at growth and decay, specifically with some examples, mostly money focused today. So, exponential growth and decay. First of all, notice we have a basic formula given here. A of t equals a times 1 plus r to the t. And this is our formula we're going to be using. I think, if I recall, yeah, we're talking money here, except example 4, we'll talk population. But it's all exponential growth and decay, so it's going to be this same setup. Notice what it says here. If r is positive, then this represents exponential growth. If r is negative, then this represents exponential decay. The idea here is look what's in my parentheses this time. So this is what's raised to my power, and it's 1 plus r. If you have 1 and you add a positive r, keep in mind my number is now larger than 1, thus exponential growth. What if r is negative? If I do 1 plus a negative r value, what's going to happen? My number is now going to be less than 1 because I'm going to be subtracting that value, and thus a decay. Now, when we're talking money, what does that little r stand for? Yeah. R is your, I'm going to say percent rate. You guys have done this before. What form do I use R in, or percent in? Okay, the decimal form, yes. If I say, is the first one 20% or something? I don't know. But if I say 20%, you're not going to put 20 in your problem, are you? You're going to go for the decimal form. So just a friendly little reminder. T, of course, stands for, what's T always stand for, guys? Time. Okay. In this particular setup, little a. What is that little a in the position of that we were talking about from the previous side? Okay, yeah. What you start with, your initial value. So R is our percent rate, T is time, A is our initial value. And the one other thing I should probably mention, A of T. What does this equation represent?
The amount after time.
Okay, the amount after time. So this is going to be our balance after time. Okay, I know they say A, thus Eli said amount, which I agree. Okay, that's good. So it's the amount, or it's the balance after T years. So I'm going to say balance after T years. And again, we've worked with interest equations over the years, so this isn't brand new to you, but wanted to throw the information out there. One other thing, almost forgot. If you are asked, I shouldn't say if, I'll say when you are asked for a growth or decay factor, they are asking you not just for the percent, but what it is when you add the 1 to it. So that 1 plus r that's in the parentheses, when they ask you in the homework for a growth or decay factor, that's what we're looking for here. It's a growth or decay, depending on the situation, factor. So just realize 1 plus r, not just the r, is your growth or decay factor. Let's look at example 3 here. See if we can get an equation set up. You invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. how much money will be in the account after 6 years? Okay? So, we are provided a formula, yes? Can you guess what formula we're going to be using? Yeah. Okay, so I'm starting with my basic formula here. A of t equals A times 1 plus R to the t. What kind of pieces can you identify here? What can you identify from the equation? What's given to us? What did you say, Keaton? Okay, time. What's my time? Okay, right there. Talks about after 6 years. So that means when we talk about t, we're going to be putting in 6. What else?
Your percent rate is 0.5 or 0.5.
5% annual interest. So that's my interest rate. It tells me flat out, yes. What is it I'm actually putting in my equation for R then? .05? Because how do we change a percent to a decimal? We move the decimal 2 places left is what I say, or do you guys divide by 100? You just know it. That works too. Okay, so you just know it. Move your decimal. There's always a 2 decimal place relationship, right? So you move your decimal 2 places left, or dividing by 100. That would get you there too. What else are we provided? You invested $1,000 in a savings account. Where's that $1,000 going to go in? The A. Okay, that is your initial amount. Can't do this problem if they don't give us an initial amount. Now, one other thing that we haven't talked about before I start plugging things in. Is this a growth or a decay problem? Growth? Because they're talking about our money growing that we put in a bank account, yes? So that means since this is growth, when we use that 0.05, that we are going to have to use it as a positive and add it, yes? If it was indicating some kind of decay, where a population was shrinking, then we'd put it in as a negative. And we'll get to an example like that. Okay, A of t, this is like our function notation. So if we're talking A of t, we're trying to find the amount after how many years? 6. So officially, if you want, we're trying to find A of 6. The amount after 6 years. Little a, our initial amount is 1,000. 1 plus r, so 1 plus 500 raised to the t, raised to the 6. What can you do before you snag the calculator up? Could we at least clean up inside the parentheses? 1 plus 500 is 1.05 raised to the 6. Grab a calculator if you don't have one, because you need to make sure you know how to use the calculator on these. Forgot to have you guys grab them at the beginning of class. Do you know how to enter this on the calculators? I would like to think we should.
Are we going to be able to use these on the chapter?
Yes. Valid question. Yes. Okay, so you will have to have a calculator this chapter. Jake just had the lovely question, is he going to be able to use his calculator this chapter? And the answer is yes. So if your calculator was banned on the last test, it is all good now. Okay? No complaints. It's just that chapter 6 that I had to ban it. Chapter 7, we're good. Okay. As far as I'm concerned, I would enter this all at once on my calculator. Most of you probably are going to do the same. If your calculator is a little more finicky, depends on you and your calculator, officially what piece of this has to be done first? The exponent. So officially, it's 1.05 raised to the sixth, and then times 1,000. However, if you use the TI like what I use, I can type it all in at once. So I can type in 1,000 times 1.05 raised to the sixth. You may or may not be able to do that. I don't know. Depends on the calculator. Here's the deal. Does your answer match my answer? If your answer matches my answer, you figured out how to use your calculator. If your calculator doesn't let you type in a big long string of things, then by all means, instead I'm going to do 1.05 raised to the sixth. However I do that, I'm going to hit equals, and then I'm going to multiply by 1,000. This comes down to knowing the calculator you like to use. Okay, if you use one of mine, they're all the same, so. How should I give this answer?
1, 3, 4.
So you put like A of 6 equals that with 2 decimal places.
Okay, so yeah, the question I should have asked a little bit better. How many decimal places should I put here? I mean, like right now, I just wrote down the whole thing my calculator gave me. How many decimal places should I give? 2, because what is this? Money. No, they didn't tell me how to round it, but you shouldn't have to be told to round. It's money. Money you always give 2. So this is $1,340.10. What? Not necessarily when you're giving your final answer. Nothing wrong with it, but I wouldn't necessarily have to have it. Okay. To make sure I get through a little bit of everything, I'm just going to talk about B. I'll give you the final answer, but B is essentially just like, I guess it's 9B. The second problem is just like the first problem. My one question I have for you is, how would I use my interest in this problem? If it's 3.5% annual interest, how do I put that in for R?
0.0.
This is a percent, so what do we do with our percent? We move the decimal 2 places left, and it becomes 0.035, yes? If you are someone and you're trying this and you want to know, I don't know, does anyone have the answer already? I'm going to tell you the answer is $593.84. I have confidence you can get that on your own, though. If you disagree, check with me and we'll figure out what went wrong. Or if we need to, we can come back if we had time at the end of class. But I want to make sure we get through what we need to here. Okay. Moving on then. Next example. Suppose you invest $1,000 in a savings account that pays 5% interest. If you make no additional deposits or withdrawals, how many years will it take for the account to grow to at least $1,500? Okay, guys, what do they provide? Start with what are they given? $1,000 is my what? My initial value, my A. 5% is my R again, my interest rate. What's different about this one? If you make no additional deposits or withdrawals, how many years? What are they asking me? Yeah. They're asking me time, and they're wanting to know for the account to grow to $1,500. What is that $1,500? That's your balance. That's your amount. That is your capital A, your A of T if you want. Now, as we go through this chapter, one of the things we're going to learn is how to solve an equation like this. You'll see when we get here in a moment, we don't really have a good way to solve it right now. So let's set up this equation. A of t equals A times 1 plus R raised to the t. Let's fill in. What are we putting in for A of t? We want to know when this equation equals what? 1,500. A is 1,000. 1 plus, what am I putting in for R? .05 raised to the t, except I don't know t. That's my goal here. I have to find that exponent. The one thing I can do is I can clean this up a little bit. It's 1,000 times 1.05 raised to the t. And what do we want to know? We want to know when that equals 1,500. Again, as of today, lesson 7.1, we don't have a way to solve this. Give us a few lessons, we'll learn ways to solve it, but we're not there yet. If we don't have a way to solve this, what are you guys doing?
Guess and check.
Guess and check? Okay, that's exactly what this is at this point in our lives. It is a guess and check. Now, if we're going to be smart about this,
You know it has to be more than 6.
it has to be more than 6. Why does it have to be more than 6, Ross?
Because on the first problem, we needed 6 and the answer was 1,300 something.
Okay, did you guys notice this is the same numbers from the first problem? So if I set up a chart here just to kind of show my progression, when t was 6, we got an answer of $1,340.10. So we know it's bigger than 6. From there, can you start plugging in numbers? You can start plugging in numbers. Some of you guys, different people are going to do different things. But remember, my equation was what? 1,000 times 1.05 raised to the, well, I know it has to be bigger than 6. You can go ahead and try 7 if you want. Or you can jump up a little bit more. So what did I get for 7? 1407. What am I looking for? We want to know how long it'll take for this account to grow to 1,500. So right now I know at 7 years, I'm at $1,407.10. So what are you doing now then? Okay, you can jump the number up a couple if you want. You can go for the next number. It's your choice. How confident are you on your calculators? On my calculator, I can arrow up to in my problem line, and you know what I could do? I can arrow over to my 7, and I can change it to an 8, a 9, a 10, whatever I want. I changed mine to an 8. Did I make it there yet? No. I can arrow up again. I can change it to a 9. Did I make it there? I overshot, but did 8 work?
No.
No, 8 did not work, and I didn't write it down. I should have. 8 was $1,447.46. 9 puts me at $1,551.33. How was my question suggested? How many years will it take for the account to grow to at least 1,500? Is 9 years a valid answer then?
Yeah.
Okay. Now, technically, it takes 8 years and so many months. Okay. And you could go in and start putting in like 8.25. That would be 8.25 years, right? So 3 months. But for the purposes of this problem, I am happy with 9 years. My work is just showing, maybe you didn't do all of those, but some of those. Okay. And Elena comments, she goes, at 9 years we shot past it, yes? So if you were doing some jumping around and and you hadn't checked 8, what should you go back and do at that point? Go back and check 8 and make sure that that didn't overshoot it as well, right? Okay. As I said, we'll start talking about logs later this chapter. And once we start talking about logarithms, we'll have a way to solve this. And it won't be guess and check. But for now, you get guess and check. Okay, where am I at on time?
10 minutes.
Okay, I want to jump down and make sure I talk about population here. So I'm going to jump down to the bottom example. If you try example 4, notice example 4 pairs up with example 2 there, yes? Okay, I will tell you, or I wrote the answer there. Maybe you don't want me to say it out loud. But I want to jump down here and talk about a population example before I run out of time. The population of a given species decreases by 20% per year. If the initial population is 150, how many of the species exist after 11 years? Okay, we're still talking exponential and growth and decay here. Now, one thing I want to point out. Did you notice the topic here? Writing an exponential function. Yes, they asked me a question here, and we're going to answer that question. But I want to talk about how we can write a function that represents this situation. So first of all, we already have a function for today, right? A of t equals a times 1 plus r raised to the t. If you prefer, you can make those p's for population. I'll actually probably change this to y's and x's here. But if we're going to use this same idea, population of a given species decreases by 20% per year. What's that tell you right there? Okay, first of all, the word decreases means this is going to be a decay, yes? What is that 20% then? What variable does that go in for? That's my r still. How's it going to go in? 0.20. You move that decimal 2 places left. 20% is 0.20, right? So 0.2. Now, what's the catch? Because it's decreasing, it's a decay, what am I going to have to do? I'm going to have to negative or subtract. And I guess I didn't really make that a negative there. But it's going to have to be a negative when we do this. What else do we have? Initial population of 150. So what is that? That's my little a. Now, hold that thought. Stop reading there. Pretend the rest of that statement doesn't exist right now. Okay, so this is part that how many of these species exist after 11 years? This is like part B on Math Excel. Let's write an equation that represents that first part. If we're writing an equation that represents that first part, little a is going to be 150. 1 plus r. What am I putting in here? Really, it's 1 minus 0.2. For the moment, do we know how many years? No, because I'm trying to write an equation. So I'm actually going to use x. I'm going to change this equation to be in terms of x and y. If that's the case, that's x. And instead of a of t out front, this is a y. Now, the one thing you can clean up here, what is 1 minus 0.2? 0.8. So if you're asked to write an equation, one way to write it is y equals 150 times 8/10 to the x. Hello. We're just finishing up some notes. I can do that. Bye. You, Kaylee, remind me. Okay. Now, y equals 150 times 0.8 to the x is one way. in my notes, if you had left it in terms of t, the a of t equals 150 times 0.8 to the t. I'll be honest, I don't remember exactly what Math Excel wants.
Pardon this interruption. At this time, can I have all seniors going on senior trips to please report in front of the auditorium? All seniors going on senior trip, please report to the front of the auditorium. Thank you.
Now, so when you're asked to write an equation, this is an equation you're writing. Now that I have this equation, I can use it to find any amount of years, yes? And what did they ask me to find here? How many of these species exist after 11 years? So what's that mean I'm doing? Plugging in my 11. So 150 times 0.8 or 0.80 raised to the 11th. Get a calculator answer. Does your calculator answer match mine? Now, my calculator answer is at 12.88, so on and so forth. What's a logical answer here? Yeah. Does 12.88 of a species exist after 11 years? No. Go for a whole number. And so we're going to say approximately 13. Okay. Your homework is lesson 7-1 in Math Excel. It is due tomorrow. I know a few of you already started it since we've started the notes on Friday. But you do need to make sure it gets finished for tomorrow, please. And again, make sure you guys know how to use your calculators. If not, see me, ask me, and I'll make sure you know how to use it.